Okay, so for this video, we will be discussing the derivative of algebraic functions. So before this, so uh, you have already studied how to solve for the derivatives using the long method. So the long method is also called the delta x, delta y substitution or whatever. So this topic is somewhat a shortcut for that no long method. So what we need to do is uh, memorize some of the basic properties of the derivatives of algebraic functions. So the first property is uh, the derivative of a constant c with respect to any variable. So in this case, we are using x, but it could be any variable. So the derivative of a constant with respect to x is equal to 0. So again, the variable here is, it could be any variable also. So we will have examples later on using different variables. So but for now, so let's just assume that all the derivatives are with respect to x. So the derivative of a constant is 0. Okay, so what is a constant? So those are parts of the function that doesn't have a variable. Okay, so say for example numbers, so those terms that are not affected by the variables. Okay, so those are called the constants. So it's the derivative of constants is 0. So another term, another property, so this one, so this is called the derivative of a sum. So uh, if we have the derivative of u plus v with respect to x is equal to du over dx plus dv over dx. So what does this mean? Okay, so we can see that we have two terms here. So uh, when our when the function that we want to derive is composed of two or more terms, okay, so all we need to do is derive each term. Okay, so it's like a distributive property of some sort, so all we need to do is get the derivative of each term. So the third one, it's called the derivative of a product. So if we have a product of u and v, so its derivative with respect to x is equal to u multiplied by dv over dx plus v multiplied by du over dx. So it means that we copy the first factor, no? Copy the first factor and then multiply by the derivative of the other factor. Plus, copy the other factor and then multiply it with the derivative of the first factor. Okay? So, in some special cases, if we have a product of a constant and a variable, no? So, all we need to do is still apply the quotient, the product rule. So, this is called the product rule, no? So, derivative of a product. So, it's c multiplied by the derivative of v plus v multiplied by the derivative of c. Okay? So, but since we know that the derivative of a constant is 0, so what will remain is this one. Okay? So, if whenever we have numerical coefficients, so all we need to do is take out the coefficient, so copy the coefficient and just multiply it with the derivative of the variable. Okay? So, last one is the derivative of a quotient. So, if we have u divided by v, where u is our dividend and then v is the divisor. So, according to the quotient rule, so it will become v multiplied by du over dx, so denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator divided by the denominator squared. Okay, so you should memorize all these properties because it will be useful later on in finding the derivative of functions. So the first derivative rule that we will be discussing is the derivative of x raised to n, where n is any constant. Okay, it could be any constant except for 0, no? Because if it becomes 0, then it will be anything raised to 0 is equal to 1, so therefore it will be a constant, therefore its derivative is 0. So this only applies if n is not equal to 0. So if we are given that y is equal to x raised to n, then the derivative of y with respect to x is equal to the derivative of x raised to n with respect to x. Okay, so the rule is the derivative of x raised to n is equal to n multiplied by x raised to n minus 1. So meaning the exponent of x, so copy it as the numerical coefficient, and then the derivative, the exponent of the variable will be subtracted by 1. Okay, so it's this very simple formula. Okay, n x raised to n minus 1. So that is the derivative of x raised to n. Okay, so let's try some examples for this. So example number 1. So find dy over dx, or find the derivative of y with respect to x for those three functions. So the first one, we have y is equal to 2x cubed minus 7x plus 1. Okay, so writing our solution for letter A. Okay, so for letter A, we are given that y is equal to 2x cubed minus 7x plus 1. Okay, so if we want to derive y with respect to x, then the derivative of y with respect to x is equal to the derivative with respect to x of this. No, so 2x cubed minus 7x plus 1. Okay, so as you can see, our function is composed of three terms. No, so according to the derivative of a sum, so according to the derivative of a sum, so when our function is composed of several terms, no, so all we need to do is get the derivative of each term. Okay, so what we need to do is get the derivative of each term. So we will distribute d over dx for all the three terms. So derivative with respect to x of 2x cubed, okay, plus derivative with respect to x of negative 7x, plus derivative with respect to x of 1. Okay, so the next thing that we are going to do is we check, no? So we have numerical coefficients right here. So here we have 2 for x cubed, and then we have negative 7 for x. So according to, let's go back to the property. So according to the product rule, the second one, for product, so if we have a numerical coefficient, we can take that out and then derive only the variable. So we can copy the constant outside. So copying the constant outside, so we have 2 here. So 2 times derivative with respect to x of x cubed. Okay, and then we have negative 7, so taking that out, so positive times negative, so that's negative 7 times derivative with respect to x of x Okay, plus. So here we can already see that we have a derivative of a constant. So derivative of a constant is 0. Okay? So therefore, so let me get another sheet of paper. Okay, so where are we? Okay, so therefore, applying the power formula for x, powers of x. So recalling, so the formula was this one. So n x raised to n minus 1. So obviously, for the first term, our n here is 3. Okay, so therefore, so 2 multiplied by, so the derivative of x cubed or x raised to 3 is equal to 3 times x raised to 3 minus 1. Okay, so minus 7. So the derivative of x raised to, so the exponent of x here is 1, right? But we can also see that dx, we will have here dx over dx. No? So it will become 1. No, or if you still want to use the power formula, so it will become 1 for n raised to x raised to n, which is 1 minus 1. Okay? Plus 0. Okay? So this will become x raised to 0, and we know that anything raised to 0 is equal to 1. Okay, so this will become 1 times negative 7. So the second term will be negative 7. So finalizing, so our final answer, the derivative of y with respect to x is equal to, so multiplying 2 times 3, that is 6 x raised to 2. So 6x squared minus, this will become 7. Okay, so that's how simple power formula works. So the second example, so we have b. So let's rewrite that here. So b is equal to, so b, we have y is equal to 5x to the negative 2 plus x to the negative 3. Okay, so finding the derivative, so dy over dx is equal to d with respect to x of 5x to the negative 2 plus x to the negative 3. Okay, so with this rule for derivative of a sum, so this one, derivative of a sum, so all we need to do is get the derivative of each term. So this will become d over dx of 5x to the negative 2 plus d over dx of x to the negative 3. Okay, so we can see here that we have a numerical coefficient. So recalling the rule for product, if we have a numerical coefficient, so take it out and then derive only the variable. So this will become, so take out 5, so 5 multiplied by the derivative with respect to x of x to the negative 2, plus this one copy, so d over dx of x to the negative 3. Okay, so the next is we apply the derivative for powers of x. So the derivative with respect to x of x raised to n is equal to n x raised to n minus 1. Okay. So here our n is negative 2. So we will have 5 multiplied by, so the derivative of this is for n negative 2 multiplied by x raised to negative 2 minus 1 plus for this one, so bring down the exponent, so it's negative 3 multiplied by x raised to negative 3 minus 1. Okay, and then simplifying that, so dy over dx is equal to, so 5 times negative 2, that is negative 10. X raised to negative 2 minus 1, so that is x to the negative 3. Minus, we have 3, and then x raised to negative 4. Okay, so for the last problem, for letter C, we have y is equal to 2x square root of x plus 1 over square root of x. So for this problem, for us to apply the power formula for x, so what we need to do is we need to express the radicals into their exponential forms. No? So this will become y is equal to 2x square root of x is x raised to 1 half plus 1 over x raised to 1 half. Okay, and then multiply this, x raised to 1 half, so all we need to do is copy the base and then add the exponents. So 1 plus 1 half, that's 3 halves. So we have y is equal to 2x raised to 3 over 2 plus, so transfer this in the numerator, so but by doing so the exponent will become negative, so x raised to negative 1 half. Okay, so with that, so we can now differentiate or derive. So dy over dx is equal to derivative with respect to x of 2x raised to 3 over 2 plus x raised to negative 1 half. Okay, so by the property, for the derivative of sum, so we will have d over dx of 2x raised to 3 halves plus d over dx of x raised to negative 1 half. No? So, since we have a numerical coefficient, so copy. So, 2 times d over dx of x raised to 3 halves plus d over dx of x raised to negative 1 half. Okay, so we can now derive. So 2 multiplied by the derivative of this. So the exponent is 3 over 2. So 3 over 2 times x raised to 3 over 2 minus 1. Okay, plus. So derivative of this is negative 1 half x raised to negative 1 half minus 1. Okay, so continuing. So here, dito siguro natin tibason. So we have dy over dx is equal to, so this will become 2 times 3 halves, that is 3. No, so 3, then x 3 halves minus 1 is 1 half. Okay, minus 1 half And then, this is x raised to negative 1/2 minus 1, so that is negative 3/2. So, x to negative 3/2. Okay? So, you can have your answer like this, or you can turn it back into radical form, no, since our given is in radical form. So, whatever form for me is okay. So, even if it's an exponential form. So, but the rule is actually if the given is in radical, so you also give your answers in radical form. So, this will become 3x raised to 1/2 minus, so return it into the denominator, the x raised to negative 3/2. So, this will become 1 over 2x raised to 3/2. Okay, so therefore it will become 3 square root of x, no, minus 1 over 2. So x raised to 3/2 is simplifying, that's x square root of x. Okay, so it is very important for you to again memorize the properties, no? So these properties, because basically those are the things that you are gonna need in the derivative of algebraic functions. So we will have a separate video for derivative of products and derivative of quotients. So that's all for this video, and then thank you for watching.